This is eet118. We're going to go over the syllabus here. This is Penn State, Fayette, Electrical Circuits 2 Laboratory. Meeting location and time, web-based course asynchronous. So that means that we don't have a time slot for this class. My name's Ronald Kalin. I have a Bachelor of Science Electrical Engineering. This is my contact info. And these are my office hours. So description of this class is a continuation of EET 105 with emphasis on student familiarization with basic electrical instruments and report writing. So you had to have taken EET 105 and take EET 114 concurrently. We're going to continue the student experience in electrical laboratory. Students will use various electrical test instruments to measure voltage, current, power, and DC and AC circuits. Experiments in this course will demonstrate empirically the concepts introduced in the companion lecture course EET 114. Report writing will be an integral part of the course. Students will reinforce safe laboratory habits. So with regard to report writing, I have two types of labs. I have an informal lab and a formal lab. The informal lab is what you're used to. You're just going to take a lab assignment like this one and you're going to go through it. This is the first lab in this course, by the way. You're going to read through it, follow the instructions, and then do the calculations. So whenever you're asked for theta 2 from figure 1.2, which is up here, this figure, you have to figure out what theta 2 is using trigonometry, using your calculator. Require definitely a calculator that can do complex numbers, and complex number calculations is required. A scientific calculator only is not going to cut it. It's not going to do it for you. You'll be able to get by this assignment, but in future assignments, you're just not going to be able to do it. So you need to get a like a TI calculator as shown in the syllabus here, or an equivalent. A TI 89 or something like that. And I went over that in the EET 114 syllabus. It contributes to the following outcomes: apply knowledge, skills, and techniques to of the to the modern tools of the discipline to electrical engineering technology activities. Apply knowledge of mathematics, science, engineering, and technology. Conduct standard tests and measurements. Function effectively as a member of a technical team. Normally, I would have you guys pair up in teams of 2 or 3, preferably 2. But since this is going to be web-based, this will all be individual. It's on an individual basis. Everybody has to do their own work and communicate effectively regarding electrical engineering technology activities. So I'm going to skip some of this. There is a lab book, okay, and I will provide all that information on for each lab, like I just showed you here. This will be provided in Canvas. And then here are some other reference books. You must have previous electrical lab experience in 105, should have taken or be taking 114, knowledge of every circuit, which is what I prefer. You need to have the every circuit app to do this lab. You can do it in other labs, but you have to be able to show building circuits on the computer and show results and give answers pertaining to those circuits from the laboratory experiment that you do. You should have lab report writing experience. Again, in a formal lab, I have guidelines on what those need to be, but basically it's going to be like writing a paper. And It's not, we're going to do a mixture of formal and informal labs, and maybe half and half, maybe a little bit less of the formal labs, but you're going to have to do at least a few of them in this course. And then computer use, the basic computer use. These are the topics that we're going to cover, and you guys can read that on your own. And then the required equipment is all provided by the university, but again, since we're not going to be in the lab in the classroom, this is all going to be done with every circuit online. The course grading, I have uh, formal lab reports 40%, attendance participation 40%, quizzes 20%. And if I don't give a quiz, this portion will go to the report section, so it would be a 60-40 split. I typically don't give quizzes in this class. And then this is the grade distribution. Attendance 100% expected, and you're encouraged to use library technical resources uh, at my discretion. Let's see here. Here's my contact information, and then homework lab report policy. Homeworks and labs will be completed using answer forms in Canvas, and each student's own handwork be submitted in Canvas, or 0 grade will be given. I highly recommend that you do the handwork first, then go in and put in the answers. Submittals to be single PDF files. Late 1 week's grace period. Homework slabs will result in deducted grades and compounding deductions. Increasingly reduced credit will result for repeating offenses. Online labs will be performed individually using an app like Every Circuit, and each student will submit their own work online in MS Excel form. So whenever we do this first lab is really kind of different from all the others. But when we start getting into building circuits and writing down tables and values and doing calculations, MS Excel was preferred. And I will usually do the first part of it for you and show you how I want it to look with answering questions and you know you're supposed to be showing an understanding of the circuit that you're building, not just popping out numbers. You need to be able to explain what's happening in the circuit, and whenever there's, questions in the lab, they all need to be answered. In the formal lab, that will be your conclusion. Like each section, each part of a lab, part one, usually there's two or three or four parts. Every part of the lab needs to have a conclusion, not just an overall conclusion at the end. There needs to be a conclusion to each part on what that part was trying to tell you, and it's usually a summary of all the questions that they ask you throughout the lab. You just answer all those questions, put them in a paragraph that makes sense and flows, and then that's your conclusion. So all homework, labs, quizzes, and exams to follow the handwork expectations document. If handwork is not submitted for any assignment or problem, any or all answers given will be considered to be wild guesses and a 0 grade will be given. If handwork does not meet the minimum requirements of the handwork expectations document, deductions will be given up to and including 0 credit. So the handwork expectations, I went over this in 114, but I'll go over it again real quick. And if you've already seen it, you can probably skip this part. But so handwork must be legible, clear, and readable, not too light or dark. Written or typed clearly on white paper or background. Having the proper header on top of each page. It's very important. Course number, assignment, the name, the date, the number of pages. I need to know definitely your name and what the assignment is. Those are vital. If you don't put that on there, I'm not going to know what it is. It needs to contain all the parts of the problem number from the homework or quiz or test or lab. Don't use the Canvas question number. That number is meaningless to me. Redraw the circuit if applicable. Write down the formula like in here and show your work here, and then show the answer in box form here. Anything less than this example will have points deducted up and including 0 credit for the problem, regardless if the correct answer is given in Canvas. If you just go in there and jump in, put 2.70 amps for your answer and don't show any of this, you're going to get a 0. You have to show handwork and scan it and submit it in Canvas. Do not forget that. So you scan and do a single PDF file. I like to use Adobe Scan. It's free. Here's a link on how to use it. And then I wrote down some quick steps on how to use it there. Please don't give me, 8 or 9 different pictures for an assignment if it's 8 or 9 pages, and send me 8 or 9 different photos. That's not, it doesn't help me, and it makes it harder on you also, and it makes it very hard for me to grade. So I'd much rather you send me one PDF file with all the sheets in it, just a single PDF. And the reasons for showing all handwork, you're showing that you know the material. You're making an effort to show that the work is coming from you, and it gives you a higher chance of getting the problem right. It leads you through a process where you can go back and double check your work and see if you made a mistake, if you have enough time. Allows for partial credit if the answer arrived at is wrong. If you make a silly clerical error or whatever, I can look at that and give you partial credit if partial credit is due and necessary. And then the rest of this is just boilerplate. I'll let you guys read it on yourselves. There's a lot of miscellaneous information in here that may or may not pertain to you or your situation. So read it on your own discretion. And then here is the layout of how I have the eet118 in Canvas. You have to go to the module section. I have the syllabus in here, the handwork expectations document we went over. And then lab reports, I have a sample lab report. And then the sample lab report gives you guidelines on how to write a formal lab report. I'm not going to go through all that. There's a lot to go through, but please read it when I say that this is a formal lab. You'll need to follow the directions in here. I also have an example lab that I did on, this is a series circuit lab that was done back in eet105. I also have a graded example of a formal lab. They got a really high score here. This is a good example of how to follow and get extra points. Um, and then here's another lab example. They might actually be the same one. I'd have to go and look, but and then here is one that they didn't do so well, and they made a lot of mistakes. So we can, you can look at that and see what they did and maybe things to avoid. And then lab assignments. I have an every circuit tutorial video in here. This is what it looks like. You just go into this Excel file in here, and then you're going to basically this is it. There is a link in YouTube, and you have to use Google Chrome to access every circuit. Um, it's $15 for every circuit, and it's a lifetime membership. You only have to pay it one time, so it's pretty cheap. It's not a bad thing to have, and you could be able to use it for other classes here too. So I recommend that. And then would be in class how to use a breadboard, and how to build an LED circuit, how to use a multimeter, how to use an oscilloscope, and then oscilloscope pointers on how to set it up. You really won't need that because we're not doing in-person labs. And then here's the manual for the new oscilloscopes that we got. The first assignment is Lab AC1, Math Review and Calculator Fundamentals of AC. And I showed you a little bit of that earlier. So this is what it would look like. And then again, you fill out the answers here. And what I want you to do is scan, once you show your work, whenever you're doing this, don't just punch in answers. You need to write down equations and show how you got your answer, put a box around the answer, and then scan it and submit it on in Canvas. Under assignments, it's going to be here. So the submittal for your handwork is LAC1 sub, which is lab AC #1 submissions. And then after you're done submitting that, go into here and there's a bunch of questions that you need to answer that are all pertaining to, the handwork that you did. You have to put in here, um, you have unlimited attempts to, arrive at your answers. And I think it will tell you which ones you got right and which ones you got wrong. So I have the first two set up. I'm not sure about the second one yet because this might be more related to an in-person lab, so I might take this one away. Um, so I think that's basically it. Quizzes really don't pertain. This is technically, these are technically quizzes. These things here and here, but like formal quizzes, I'm not sure we're gonna do in this class. And then I think that's basically it. All I wanted to talk about eet118. So if you have any questions, let me know.